experience in collecting electromagnetic articulatory data for the Russian language. Yeah. So, yes. So, yeah. First, I will mention the methods for capturing articulatory movements, then the technology we use, and then I will describe shortly the recording procedure and the results we get. So here are the methods. Some of them you use a lot, I think, as MRI. And the other is electromagnetic articulography, which we use. Then there is ultrasound imaging and X-ray cinematography and palatography. There are two types of palatography, which is one of them is electropalatography, and then optical, new kind, which is optical electro-optical palatography, where they use lasers. So, what is EMA technology? For those who don't know how does it work, there is a large electromagnetic field generated by these large coils. And the speaker should sit in such a way that his head is in the center of this electromagnetic field. And we attach sensors to his articulators, which are small microcoils also, and they interfere with this large electromagnetic field. And by this interference, we can capture their position. And also, there are a couple of reference sensors attached to motionless parts of head, which are used to normalize head movements during speech. And it's announced that it's not dangerous for health, as X-ray cinematography, for example. So speaker feels comfortable just sitting and talking. As there are these reference sensors to normalize head movements, speaker actually can freely move head within this electromagnetic field. And this technology has high temporal resolution and high spatial resolution. And so actually we can capture the corticular effects and the articulation in spontaneous speech. But actually, the truth is that it's not so easy to sit for a couple of hours. So speakers get tired, and there are some health restrictions because people with pacemakers cannot step into electromagnetic fields, so we cannot record them. And it's not recommended to move actively head because the normalization is not, it can normalize smooth movements, but not rapid movements of head. But still, the restrictions are not so bad. So why do we need this EMA corpora in general? It's for Russian language, a new source of articulatory data. For dynamic speech, has high quality of articulatory data. It's easy to process it automatically as we get oscillators. And there is no need for automatic image processing. And here are various potential research applications. There are phonetic research of co-articulation effects, of modeling the the informational technology field, they use this data for articulatory to acoustic transformation for speech synthesis purposes. And also you can make speech recognition using articulatory data. There are not so many available EMA corpora. Actually, there are two main corpora. They both are for English language. First one is quite small one, but the other one, this one, is pretty large. It's made in Edinburgh, and they have almost all kinds of articulatory data, which are MRI, ultrasound, electromagnetic data, so they can compare it. And what we want to do is to record some 10 people, and we started to do it, and to record pretty large amount of utterances. So that's how does it look. The speech quality is pretty nice. So it's 16 kilohertz with 16 bits sample rate. We can get XYZ coordinates and also two angles relative to two planes. But we need to do noise reduction. So we have special power supplies filters to reduce mains hum, which interfere into electromagnetic data. And also we do some post-processing for speech signal to reduce noise from cooling fans of the device. We have a relatively quiet room, so the speech quality is pretty nice. We use professional unidirectional microphone, and we place it 1 meter ahead of the device, because you should keep all the electromagnetic devices as much in the distance which is larger than 1 meter, so that it will not interfere with electromagnetic field. So this is the places where we attach our sensors. We have 3 reference points on the motionless parts of the head. It's left and right mastoids and nose bridge. And then we put sensors to the articulators. So it's center of the upper lip and lower lip, left and right mouth corners, back of the tongue, and we try to put it as far as it possible. We attach sensor to the tongue tip, and then to the point in the middle of the tongue. And also we attach one sensor to the center of front lower teeth, so that we can track the lower jaw movements. So that's a photo of the attached sensors. I should say that it's easy to glue sensors on the facial skin. There are some restrictions that men should be well shaved, because it's because once you glue it to the hair, it's very hard to detach it. So, and then you shouldn't use cosmetics, because sensors tend to detach themselves. That's easy part. And then comes hard part, how to glue sensors inside the mouth. Because skin should be completely dry. You understand, yeah. Because otherwise, the sensor will fall I don't know, in 5 or 10 minutes. So what we do, we use a hairdryer to dry skin inside the mouth. Yeah. Yeah, true. The other thing that speakers may experience this gag swallowing reflex, especially when we put sensors to the tongue root. The other thing that minimal allowed distance between sensors is 8 millimeters, because otherwise the electromagnetic fields of these sensors, which they produce, will interfere each other, and then we can get some noise in electromagnetic data. So you cannot record passive and active articulators in one session. Somehow you should record them separately. Because if you place one sensor to the palate, and then the other one to the tongue, then they will be too close to each other in some moments of speech, during the speech. So here is the general recording procedure. We warm up computer for a couple of hours. Then we do its calibration. You should do it each time you make experiment. Then we record small sessions of motionless speaker with silent speaker, so that we can capture the positions of reference sensors, and we use this information for normalization. And then we record palate shape. So we have these reference sensors attached, and then we glue sensor to the small stick, which shouldn't be metal one. So actually it's wooden. And we move it along the palate. So we catch its shape and use this information during the analysis. And then we record speech, all the sessions with all the speech data we need. So the whole experiment takes the whole procedure takes something like 4 or 5 hours. Actually, it's the whole day. So here are some difficulties we get. So as I said, speaker gets tired during sitting in this cube, even it's transparent. And then sensors, as you see, the sensors are pretty small, but they still have some volume. They're about 1 millimeter in diameter. So the speaker cannot touch the palate with his tongue as he used to. There is always some space between the tongue and the palate. And the other thing that there are, as you see, there are some electrical wires here. So while speaking, speaker can bite sometimes them when putting teeth together. That also disturbs a bit. So the speech is not perfectly natural. And I don't know if it will sound.
Küvet, bюvet, tur, vor, atvar, apora, apara.
As you hear, some sounds are not natural, like because you cannot flap correctly the tongue tip to the palate. And also there are some difficulties with the sounds like T and D. But still it's okay, especially when speaker used to this device and to the sensors inside his mouth and to the wires going outside the mouth. So this is the material we record. We record syllables, lists of separate words, small paragraphs of text, and we have some of you know, we have these phonetically representative texts, and we record it also. So we also do some speech annotation. We developed tools for automatic detection of pauses and pitch, especially pitch periods. The only thing which should be done manually is sound annotation, segmentation and annotation of sounds. And then we can do automatic word segmentation. So that's what we do with articulatory data. So we normalize them. This means that actually these procedures abstract the position of reference sensors from the position of articulatory sensors, so that they are not moving. After that, they should make some smoothing, and then we do detection and labeling of extreme and inflection points during these motions. And also, we convert the data into the sound waveform so that we can use software for sound analysis to analyze the articulatory data. And here are some conclusions that even there are some restrictions for recording, the EMA is a good technology for observation speech dynamics. It's not an easy task to record the data, and we plan to publish this corpus online once we have enough data. And here is some short appendix. These are the experimental results I got once I used this articulatory information for sound recording. So these data, they are as good as, so I got the results which are as good as with using acoustic data. So you can use both. Yeah, thank you. Do you have some questions?
Questions for Daniil, please.
Thank you. A fascinating method. Certainly better this than sitting in an X-ray machine. How high is the field?
Sorry?
How strong is the magnetic field?
Oh, I don't know how strong it is, but you don't feel it. I mean,
you measure it in Tesla, in picotesla, in
I don't know.
And could you combine it with an MR recording at the same time, with a functional MR?
All right. I don't think so, because even if you bring some metal devices into, I mean, you can't use cell phones or computer just in this cube.
You'd have to reduce the, okay.
I mean, we put everything in the distance.
Do you have to have sensors with wires attached to them?
Yes.
Couldn't they be just smaller coils? Wireless, you could induce current in by using the field. That would make it a lot easier.
Maybe that's the future of this technology, but now we use the wires to get the amplitude of the power generated by these microcoils. Otherwise, you should transfer it in a wireless way. I don't know, probably some next generations.
More questions? I have a question about those articulations that are distorted because you have the sensor there, the flaps, the stops. is there any strategy to somehow do some kind of a repair for that?
The strategy is that speaker, while speaking, he used to this feeling, and then he pronounced a bit more naturally.
Training is the strategy.
Training, actually, speaker training.
This makes sense. Any more questions or comments? Let us thank Daniil.
Okay.